Welcome to my presentation entitled Examining the Work Experience of Programmers with Visual Impairments. My name is Earl Huff Jr., and I'm a doctoral candidate at the School of Computing at Clemson University. I am presenting on behalf of my collaborators, Quadro Boateng, Michaela Moster, Dr. Paige Rodegero, and Dr. Jolien Brinkley. For this presentation, I will first outline the purpose of the study and its objectives. Then I will briefly talk about the interview methodology and the participants involved in our research. Following will be the findings from our study and some takeaways of our work to conclude the presentation. The purpose of our study was to explore how certain workplace dynamics in software development teams may affect the work practices of programmers who are blind or have low vision. We also wanted to uncover if and how any challenges in the workplace may affect how blind or visually impaired programmers contribute at their jobs. Lastly, our study explored what blind or visually impaired programmers see as areas of improvement to increase accessibility in software development environments. We conducted semi-structured interviews with 11 blind or low vision programmers about their work experience, the challenges they encountered, and how conditions could be improved. Participants were recruited through email advertisements sent through a mailing list for blind or visually impaired programmers and spread by snowball sampling. All interviews were conducted by phone or video call and lasted between 25 to 40 minutes. So now I'm going to discuss our findings, beginning with challenges found in the workplace. One of the issues raised by the participants is workplace dynamics. These included having to relegate tasks they deemed inaccessible to their coworkers while focusing on tasks they found more accessible to do, and collaborative activities with coworkers who may not have experience working with someone with a visual impairment. For example, pair programming or working with visual information such as UML diagrams. Inaccessible software development tools have been a common problem mentioned in prior work, and it's no surprise that it comes up in our interviews with the participants. From complex user interfaces to inconsistent navigation, such platforms have forced participants to use simpler, less sophisticated editors as a replacement or supplement in their line of work. Also mentioned in past literature that also appeared in our interviews are challenging tasks such as code navigation and debugging. Because screen readers move in a linear fashion, blind or visually impaired programmers have to read code line by line, whereas sighted programmers can skim code, even skip lines. User interface design is another task mentioned by participants as being challenging because it is primarily visual and certain elements of the task is inaccessible depending on their degree of visual impairment. Now we will talk about what participants believe are ways in which their work experience could be improved. The most critical area brought up by our participants was improving tool accessibility, in particular the simplification of the user interface to make navigating the tool quicker and easier. Additionally, enhancing the view of the code base, perhaps with some form of in-editor zoom feature to zoom in or out to help programmers get a better view of the code. In terms of quality of life improvements, participants mentioned video tutorials on how to use tools such as IDEs as a visually impaired person. Also, built-in documentation or manuals for keyboard shortcuts and commands for IDEs may help serve as a reference to ease the cognitive load of blind or visually impaired programmers, given they typically have to commit such shortcuts to memory. Some participants even mentioned the necessity of companies that develop software development tools to include input from blind or visually impaired programmers to help produce more accessible designs. There's a concern that many companies develop their technology under the assumption that a typical programmer does not have any degree of visual impairment. To conclude, here are some takeaways from our study on how to provide a more accessible work experience for blind or visually impaired programmers. The biggest takeaways are flexibility in the tools they can use, assigning tasks that capitalize on their strengths and avoiding visually demanding tasks such as UML diagrams, and working with blind or visually impaired programmers in developing documentation and training on using software tools that are not accessible by design. The last point stresses the necessity of companies developing software tools to include input from blind or visually impaired persons in the design of future tools to ensure that they are accessible upon launch. With that, I end my presentation. Thank you for your time.